Thank you for joining Portrait Pharmaceuticals for our series on aspects of method validation. Today we will be discussing quantitation limit and detection limit. The quantitation limit of the method is the smallest concentration in which a result can be quantitated accurately. The concentration is determined by preparing a solution that yields a signal-to-noise of 10. Typically, this is done by diluting a standard preparation. Similarly, the detection limit is determined by diluting a standard until a signal-to-noise of 3 is obtained. This is indicative of the smallest concentration which a peak can be detected. For validation purposes, the QL solution is injected 6 times and criteria are set for the peak area, percent RSD, and the average signal-to-noise. The detection limit solution is only injected once for verification. To further explain this, we will dive into what signal-to-noise is a little more. There are many ways to calculate the signal-to-noise ratio, but our focus for this discussion will be around USP signal-to-noise. The USP signal-to-noise calculation is 2 times the height of the peak divided by the noise. The region of the noise should be taken over the range of 20 times the peak width at half height. For example, if the width of the peak at half height is 10 seconds, then the noise region selected should be 200 seconds. On the right of the screen, there are a couple of real-life examples of a sensitivity solution. As you can see, the noise of the baseline has a significant effect of the determined signal-to-noise ratio. Per the ICH guidelines, the QL must be determined for all assays regardless of the phase of the program. The DL is not required until the quantitative assays are further along in the development life cycle. It is important to understand the limitations of your method so that you are not reporting values that are not accurately quantitated. Determining QL and DL provides clear boundaries for reporting results. Please reach out if you have any questions or would like to discuss other ways to calculate signal-to-noise, QL, or DL. Thanks again for joining us.